In the upcoming videos, we're going to look at two of the important data structures that deal with intervals, segment tree and interval tree. And to motivate them, we look at this problem that we call the windowing problem. The problem is the following. We have a set of n disjoint line segments in the plane, and we would like to store it in a data structure such that, given a query rectangle, we can find all the line segments that intersect this query rectangle. This includes the line segments that are completely inside, as well as the line segment that intersect the boundary. The motivation is kind of clear, kind of easy to see. Imagine that we have like a picture or a map or something, and the user has this viewpoint, which is this rectangle over here. So the screen of the user is over here. We want to find what are the segments that are seen by the user, and then we would like to display them. To find the line segment seen by the user, we just have to find everything that is inside here. Okay, so getting away from that picture, the picture that we could have, or as a mental picture to deal with this problem, is something like this. Okay, so we have n line segments that are disjoint, and that's a query. We could classify the segments that intersect the query rectangle as two types. The segments that cut through this rectangle, like these green ones, and the segments that have an endpoint inside. Either they have two endpoints inside, which means they're completely inside this rectangle, or they have one endpoint inside. To find the segments that have at least one endpoint inside this query region, we could use orthogonal range reporting. In other words, we could just store the endpoints of the rectangles in the data structure, then find all the endpoints that are inside this query rectangle R. We know how to do this using range trees. This is what we learned the previous week. So the only thing that is left to solve is to find these green rectangles. First, we look at the simpler case when the rectangles are horizontal and vertical, and then we solve the general case when the rectangles can have arbitrary orientation. The reason we do this is because we're going to use some interesting ideas for this case, which is a bit different from the ideas that we use for the other case. So it's kind of good to know both techniques.